Hi guys! Welcome to the last video of the quarter of the year. We're there. We did it. We made it. We survived e-learning. All right, so today we're going to talk about logarithms, which should be a review. You should have done them at some point in your life. I think Algebra 2, maybe Algebra 1. I don't know. They're there. Logarithms. We just need to review these, especially for those of you going on to calculus after this. Logarithms are extremely important, specifically natural log. Log to the base power of e. That is going to be extremely important. It's going to pop up a lot in calculus. So I just want to make sure that you have these basic properties again and that you remember how to apply logarithms to solve problems so that you can use that next year in calculus if that's where you're headed. So let's just review the properties first. Remember, there is one called the product property. And the product property says this: if you have a log base b of something such as m times n, well then you could rewrite that in an expanded form as log base b of m plus log base b of n. Because it's a multiplication, you put a plus sign and separate it into two separate log problems. Similarly, if you use natural log, now important thing to remember, natural log is the same thing as log, it's just that it's log base e of some number. And e represents a value like 2 point, I don't remember, I think it's like 2.71, that's probably not right, but it's 2 point something. It is just a constant that exists, kind of like pi. It's an important constant number that exists in exponential functions. So log base b is the same thing as using like log base e. We just refer to it as the natural log because it's the natural growth of things. So ln is log base e. So the ln works the same way. If you have ln of, in my example, I have 10 times x. Well, you can separate that into natural log of 10 and natural log of x being added together. The opposite of that is the quotient property, which shows that if we have log base b of m over n as a fraction, or m divided by n, you could rewrite that as a subtraction problem, log base b of m minus log base b of n. Again, similarly, log base e, or natural log, of x over 5 can be rewritten as natural log of x minus natural log of 5. So you can rewrite that as a subtraction problem as well. And the other really important one is the power property. The power property is extremely important in solving logarithm problems. If you have log base b of m to the n power, you have an exponent. Well, you can take that exponent and move it into the front of the log. So it can be rewritten as n times log base b of m. I didn't write the natural log one, but it works the same way. Natural log of x to the third can be rewritten as 3 natural log of x. Same thing. The reason logs are super important is they help you to solve exponents. If you have an exponent and you need to solve for x, and x is especially in the exponent, you're going to use logarithms to do that. And that's really the main purpose of them. So let's first look at some expanding problems. I've got some condensing, some expanding, and then some solving problems. It's kind of all crammed into one quick lesson. I purposely gave you like small homework assignments as well as no quizzes this week because I want to make sure you had time to practice all these things. So I've got two questions here. Condense the following. So starting over here, I want to condense 3 natural log of pq plus 4 natural log of pq squared. So I'm going to try to condense this. Well, the first thing I want to do is I got to apply the power rule. Notice how there's a 3 and a 4 out front here. I want to make those go away. So I'm going to put them back inside here as powers. So ln of pq cubed plus ln of pq squared to the 4th power. So I'm putting these back in as powers respectively. Well, then I need to make sure that I apply this power to everything in there. So this could become ln of p cubed q cubed. And over here I can have the natural log of p to the 4th, and remember when you redistribute this and you multiply, so q squared and to the 4th power is going to be q to the 8th power. Well, now I can combine this one more time to finish condensing it. I'm going to make it 1 natural log. Because it's a plus sign, we know that multiplication is happening here. So I have p cubed q cubed multiplied by p to the 4th q to the 8th. And remember, when you multiply with exponential powers, well, p times p times p is p cubed, and p times p times p times p is p to the 4th. Well, p times p times p times p times p times p times p, so p cubed times p to the 4th is p to the 7th. You add the exponents together when you do that. So I end up with p to the 7th, and q cubed times q to the 8th is going to be q to the 11. There's 11 q's being multiplied, and that would be your condensed version. Coming over here to this next one, same thing. We're going to take this power and put it in first. Right? So this first one's going to become log base 3 of a to the 3/2 power. And let me say this real quick. In what I'm supposed to teach you, really the focus should be on natural log, because that's what you're going to use in calculus. You're not going to use log base other numbers very often. With that said, the materials and resources I have has them mixed together, and so I'm just going to give them to you mixed together. And that's okay. It's going to still help you practice the skills, but I really want you to be comfortable with natural log. If natural log is still holding you up and you feel confused by that, please talk to me, because I need you to make sure you understand that before you go into next year. All right, so coming over here then, we've got this minus sign, and we put the 1/4 up here. Based off what we just did, I think you can see what happens. This 1/4 is going to apply to the 16 and to the a squared. So it's going to be 16 to the 4th power, which we could put in a calculator. If you did that, you would get 2. And then a squared times 1/4, so it's going to be 2 times a 4th, which is a half. So it would be a 1/2. So I have 2a 1/2. Well, now since they both have the same base, I can rewrite them as log base 3 in one form. A minus sign means do division, so we're going to have a to the 3/2 over 2a to the 1/2. Remember, if you have division of powers with the same base, you can subtract. So I can take this a to the 3/2 and subtract a to the 1/2 from it. So log base 3, the 2 is going to stay on the bottom. Well, if you take 3/2 and subtract 1/2, you get 1/2. So it's a over 2, and this would be my condensed form, log base 3 of a over 2. Put that up real quick. I know there's a lot of properties there you could have forgotten. Maybe the dividing powers properties, multiplying powers properties. It would be worth looking into those again if you're not super comfortable with those. Example 2. So example 2 says we want to expand the following. So we're going to do the opposite. So in this first one, well, there is no multiplication directly happening here. Natural log of x squared minus x minus 2. But I definitely can simplify x squared minus x minus 2 through factoring, right? I can factor that into 2 pieces. So what 2 numbers, put my x here, what 2 numbers would multiply to make -2 but add up to make -1? I think that's going to be -2 and +1, right? -2 times +1 gives us -2. -2 plus 1 is going to give us -1. And now I have a multiplication problem. Now there's a multiplication problem right there. X minus 2 times x plus 1. So I can rewrite this as ln of x minus 2. Because it's multiplication, we'll put a plus. And ln of x plus 1. Done. Expanded. Over here with the log base 4 of c squared over d to the power of 4. First thing we're going to do is take that power and move it out. So I'm going to have 4 log base 4 of c squared over d. So now I have these 2 pieces that I can separate, right? I can have 4 log base 4, and I have a c squared on top. And then since it's division, we'll put a minus and do 4 log base 4 and put a d. At this point, there's only one other thing you got to worry about, and that's that 2 right there. We can pull that 2 off and make this 8 log base 4 of c minus 4 log base 4 of d. And that would be my fully expanded form of that one. Right there. I think I did it backwards, didn't I? Did I do it backwards? No, I did it right. Sorry, I'm just going crazy. Okay, example 3. Bear with me. My notes are really ugly here. I ran out of space, so you may want to make sure that you pause it and copy it from here. I'll still put my notes up so you can see it, but it got pretty ugly. So the first one is the one that's really important, is solving using log, natural log, right? So what I need to do here is the first thing I need to do is try to condense it into as few pieces as possible. So since I've got this natural log set up here, let's start by taking here. I've got 3 times the natural log of 2. This tells me that the power property was used here. Right? I moved that 3 out. So let's move it back in. So I'm going to have my plus sign, and I'm going to have ln of 2 to the 3rd. Right? Apply the power property. Well, since they're both natural log, I know I can rewrite this as a multiplication problem. ln of r plus 1 times, well, 2 cubed is 8, so we can just put an 8 here instead. Times 8. Rewriting that as one thing equal to 7. I forgot to have equal to 7 up here too. And then I can take that 8 and distribute it. So I end up with ln times 8r plus 8 equals 7. Now is the part I think where a lot of people forget how to use this. Remember to use natural log. It's the inverse of taking the power of its base. For example, log base 4 is the inverse of taking 4 to the x power. Log base 7 is the inverse of taking 7 to the x power. Log base e, or natural log, is the inverse of taking e. So what I'm going to do is I'm going to put e to the both sides. E to the power of 7 and e to the natural log of this 8r plus 8 thing. What ends up happening here then is that the natural log and the e cancel each other out, so I'm left with 8r plus 8. Over here, e to the 7 is going to involve us using our calculator. If you took e to the 7, you would get 1096.63. I don't have a calculator in front of me. 1096.93. Is that what I said? I think I said that. Maybe I wrote down the wrong decimal. I don't know. And then we could just solve it from here. Subtract 8, divide by 8. Let me just show you over here. When I subtracted by 8 and divided by 8, I got 136.08, and that's what r would equal. So that one's not super ugly. The other one is a mess. All right, the other one. So in this one, I have 3 to the power of 4x plus 1 equals 8 to the power of 8x plus minus 5. So what I'm going to do is I'm going to take the log on both sides. You can take the log of a specific power. I just took log like this. Log of 3 times 4x plus 1 equals log of 8 times x minus 5. In case you don't remember, this means log base 10. That's the standard log that's in your calculator. So doing it this way allows you just to use your calculator as it's taking log base 10 of both sides. You could just use the log button in your calculator. Well, we're going to apply some properties here. Because this is the power property, I can take this power and move it down. So these powers that originally I couldn't set equal to each other, now I can move them out into the problem. So this becomes 4x plus 1 times log base 3. Sorry, log 3 base 10. And over here I have x minus 5 times log base 10 of 8, or just log of 8. Well, now I can do some distributing here. Distribute this log into here, so I end up with 4x log base 3, log of 3, plus 1 times log of 3, so just log of 3. And over here I multiply and I have x times log of 8 minus 5 times log of 8. So my last really important step here is just to kind of organize some things in a way that we can actually solve. I want to put all the x's to one side. So it looks like this and this are going to come and be my x's on one side, and then put all my just regular constant logs on the other side. So I'll put the plus log 3 and the minus log 5 log 8 on one side. So I'll just leave the 4x log of 3 as is. But then I'm going to move this x log. So I'm going to subtract minus x log of 8. So this will become minus x log 8. On this side, we're going to have to minus log of 3 to move it over here. So I have minus 5 log of 8, because it was negative, and then minus log of 3. Now I can do some stuff here. I can factor an x out here first. So I end up with x times 4 log of 3 minus log of 8 equals negative 5 log of 8 minus log of 3. And then I can divide everything. Divide 4 log of 3 minus log of 8. And do that on this side for log 3 minus log of 8. These will cancel, so now I'm left with x equals, and this would just be punching it in your calculator. To find the log of 8 times negative 5, subtract the log of 3, find the log of 3, times it by 4, subtract the log of 8, and divide those two things. And if you do, you would end up with, I think that's negative 4.9, hold on. Negative 4.97, I think. 4.97. And that would be your answer for that one. So that one's a little bit more challenging, a little bit tough, but I only gave you like 8 problems of that. So let me know if you need more help this week so I can help you with this. Make sure you're on the right track. Best of luck, everyone. Have a great day. Bye.